This is the Geometry Chapter 3 Final Review. Chapter 3 was all about parallel lines and the angles that are created from them, and talking about the angles of triangles as well. So we've got a lot of objectives to kind of get through. We're going to identify relationships between figures in space. We're going to identify angles formed by two lines and a transversal, and then talk about what happens to those angle pairs when you have parallel lines. We're going to use those properties of parallel lines to find measures. We're going to decide if we have parallel lines looking at angles. We're then going to talk about relating parallel and perpendicular lines. We're going to use parallel lines to prove theorems about triangles. We're going to find the measures of angles of triangles. We kind of did some stuff with constructions. We're going to graph and write linear equations, and then we're going to relate slope to parallel and perpendicular. So there's a lot of stuff in this chapter, but it was a really good, important chapter. So it says students will be able to identify angles formed by two lines and a transversal. This was the first thing. It says, what are the names of the angle pairs in the image to the right? So there were several different angle relationships we talked about. There was linear pair or adjacent. There are vertical angles. There are same side interior angles. There are alternate interior angles. There are alternate exterior angles. And we also talked about corresponding angles. So why don't you try to fill in as many relationships as you can, and then we'll talk about them. All right, you can check your answers with mine. The first one, angles 1 and 2 are a linear pair or adjacent angles. 2 and 3 then were vertical angles. They're opposite each other. 3 and 6 are alternate interior. They're both inside those parallel lines between them and on opposite sides of the transversal. 4 and 8 were corresponding angles. They're both on the bottom right of the intersections. 2 and 7 are alternate exterior. They're both outside of those two lines and on opposite sides of the transversal. And 4 and 6 are same side interior. They're both between the two lines and on the same side. Okay, so that's kind of going through those. What you're going to do down here now is you're going to come up with as many pairs of each one of these relationships as you can from the picture. Now, the numbers are, this picture is numbered differently than the picture up above, so don't just all of a sudden go off of that one. And I'm going to tell you that you could have up to 4 different angle pairs with each relationship. So look for some of these. Some of them might just have one that you can list right now, but try to get as many of these as you can. Although I will say for adjacent, if you just want to give me one pair of adjacent angles, that's probably good enough. So pause the video, see what you can come up with. All right, you can check your answers with mine. For vertical, I got 4, 1 and 7, 2 and 8, 3 and 5, 4 and 6. Alternate interior, I got 2, 2 and 6, and 7 and 3. Same side interior, I got 2 and 3, and 7 and 6. Adjacent, I got 8 and 7. You could have a lot of different choices for adjacent. That's the only, I just picked those ones. They just have to be next to each other. Corresponding, there's 1 and 3, 2 and 4, 8 and 6, and 7 and 5. And alternate exterior, there's 1 and 5, and 8 and 4. Okay, so the reason why these were such a big deal was because of the next thing we talked about. And after we were able to identify relationships, we said, hey, if those two lines are actually parallel, we actually have congruent or supplementary angle pairs. And so in this picture here, you have one angle measure of 110 degrees, and that's actually all you need. You can get every other one of these angles, and that's what you're asked to do over here on the left. So why don't you pause the video and see if you can come up with as many other angle measures as possible. All right, you can check your answers with mine. I got angle 1 is 70, 2 is 110, 3 is 110, 4 is 70, 5 is 70, 7 is 110, and 8 is 70. All of this is brought along by knowing I have corresponding angles, knowing I have vertical angles, I have a linear pair, I might look at alternate interior, alternate exterior, but that's what we end up with for all of these. In this next one, what I'm going to ask you guys to do is come up with some angle pairs that have these relationships. So it says 3 pairs of angles in the diagram that have the given relationship, supplementary or congruent. So why don't you pause the video and come up with 3 different angles that have that relation, 3 different angle pairs that have that relationship. So for supplementary, I just focus on the angles that 1 is supplementary with. 1 is supplementary with 2, with 8, and then you can go across the other intersection with 4 and 6 as well. If you want to talk about what angle 2 is supplementary with, it's supplementary with 1 and 7, 3 and 5. You can kind of keep building like that, which is why down here I kind of just wrote 2 long strings of congruent statements. 1, 7, 3, and 5 are all congruent, and 2, 8, 4, and 6 are all congruent. So double check that yours can be broken apart from those congruent statements to make sure you got them right. Otherwise, you're good. All right, so then we moved on to talking about, well, let's look at these angle measures and decide if we do have parallel lines. So this is when we talked about the converses. So we had like the alternate exterior angle theorem, the alternate interior angle theorem that say if you have parallel lines, these are congruent. But then we said, well, the converse is also true. If these angles are congruent, then the lines are parallel. So if I look at this picture right now, what I would identify, it says, given the information in the diagram, are the lines L and M parallel? If so, why? I would look at these 2 angles that are marked with these congruent marks, here and here. What's their relationship? Well, they're inside the lines and they're on opposite sides, so that's your alternate interior angle. And they're congruent. So yeah, that is your so are the lines parallel? Yeah. That's going to be your converse of the alternate interior angle theorem. Now, if these were, if that changed, you might not be able to say that if you had different markings, but you want to look for what angle relationship do they have, and then it's the converse of that theorem usually. So it says, using the diagram below and the given information, decide for each given piece of information if the lines are parallel. So I'm going to just tell you heads up right now. 2 of these are yeses and 2 of these are nos. So why don't you pause the video and try to figure these out. Which ones are going to be your yeses and which ones are going to be your no with the given information. So if I look at these first one, the first one is a yes, and actually the third one is a yes, and then 2 and 4 are no's. So 1 is a yes because 1 and 5 are corresponding angles, and by the converse of the corresponding angles postulate, if those are the same, the lines are parallel. 2 is a true statement, but it's not enough information. 3 and 4 are supplementary. That's great that these 2 add up to 180, but I need to know something about one of those 4. So that was just not enough information. Then if I go down to number 3, it says 5 is 70 and 2 is 110. Now there isn't a relationship between angle 5 and 2, but there is between 5, 1, and 2, because like 5 is corresponding with 1, so if that one is 70, then these would be the same. Well, since 2 and 1 are supplementary and 70 plus 110 is 180, then yeah, I can kind of do this roundabout way of determining that yes, those are in fact parallel that way. And then 7 is 65 and 3 is 115. Well, those are corresponding, so they should be the exact same for the line C parallels. That's why that one doesn't work. All right, so after we kind of established all these converses and original theorems for all these angle relationships, we then got to talk about triangles. So the students will be able to find the measures of angles of triangles. Remember that there is always a really important relationship between the angles of a triangle. They always add up to 180. So it says, what are the measures of angles 1, 2, and 3? Well, notice in this picture, all 3 sides are the same. If all 3 sides are the same, it means all the angles are the same thing too. So if you have 180 and each angle is the same, you just divide it by 3. They're all 60 degrees. They're each going to be exactly the same amount. Okay, and we're going to build off that down here to kind of figure out some of these angle measures. I'm going to give you 2 hints to help you out here. Look for isosceles triangles, and then pay attention to any exterior angles. We did have the triangle exterior angle theorem. So pause the video, see if you can come up with as many of these as possible. All right, let's take a look at those first 2 up here. It says find x and y. I noticed I had a 90-degree angle and I had an isosceles triangle, which means that these 2 angles are both 45. So I just set up an equation for both equal to 45. I got x to be 25 and y to be 5. On the next one, I did something similar. I noticed this is an isosceles triangle again with these congruent marks on the sides, so the bases are the same. So I've got 30 and then 2y is also 30. That got me y. Well, then I also knew all the angles add up to 180, so I just took 180 minus 30 minus 30, and I got 120, which might make you be like, well, wait a second, that picture doesn't look like that. Remember, the pictures aren't drawn to scale, so yeah, it may not look accurate. That doesn't mean it's wrong. I move on to the next one down here. I remember the triangle exterior angle theorem, which says that, hey, if you have an exterior angle, it's actually congruent to the sum of its two remote interiors. If you didn't remember that, which a lot of people don't, here's your other option of what you might have done. You might have then replaced this and said, hey, that's got to be 110, and gone 7x plus 3x plus 110 equals 180. That still should have gotten you the exact same value for x, and it's perfectly fine to do that. And then this last one, I said, well, all three angles must add up to 180. So that's what I wrote in this first line, and then I started to simplify from there and got x to be equal to 6. Okay? So those are kind of your trying to find the missing measures of angles, and trying to find these variables. But it does also to say to find the measure of the labeled angles. So let's just go back up and rewrite these angles. I'm going to write the angles in black, just so they stand out. We already talked about how both those angles are 45 degrees, so we know those. Over here, we got one of them to be 30 down here on the bottom right. The top one's just x. That one's got to be 120 degrees. Go down to the bottom left. They want these marked angles here and here, so just plug the 10 back in, and I get 70 degrees, plug the 7 back in, and I get 49 degrees and 21 degrees. Go over to this next one, just go plug that 6 back in for x. Plug it up here on the top. I go 8 times 6 plus 12. That's 48 plus 12. That's 60. And down here on the right, 5 times 6 is 30 degrees. Don't forget to actually make sure you answer the question fully. Always look back when you finish to make sure that you've answered every detail. So here it says students will be able to graph and write linear equations. It says, what is the graph of y equals 2/3 x plus 1? And the next one is, what is the graph of y minus 3 equals negative 2x plus 3? These are two different forms we talked about. The first one is your slope-intercept form. So it's pretty straightforward. It's just your y equals mx plus b. This 1, that's your y-intercept. So you go to the y-axis, you find 1, you put a dot. Pretty easy. Slope's positive, so that means it's your rise over your run. We're going to go up 2 over 3, so we go up 2, 1, 2, over 3, 1, 2, 3. We put a dot. Now, I like to put a few different dots so that I can get a better straight line, because I can't really draw a straight line very well. So I might go up 2 over 3 again. I go up 2 over 3, up 2 over 3, and I get these points to make my line. Now, you can also go back the other direction, and that's just going down to right or left 3. So I might do that as well, down to, because remember, can't really draw a straight line very well. Down 2, back 3, down 2, back 3, and I get a line like this. I'm going to label this one A because it's problem A, and we're going to go do B next. This is the one that kids struggle with. It says y minus 3 equals negative 2x plus 3. This is what we call point-sloped form. So in this form, you can actually pull out, instead of the y-intercept, you can pull out an ordered pair. And you pull it out of right there and there. The format for this is y minus y1 equals m times x minus x1. So your ordered pair, you want x1 and you want y1. So I go look, well, positive 3, it's minus x1, so it's the opposite sign. So it'll be a negative 3 for my point. And then it's y minus y1, so it says y minus 3. Well, 3 must be my y value. And you actually start by graphing that point. So we're at negative 3, 3. I go 1, 2, 3, 1, 2, 3. I get a dot. Then, once you have your point, it's called point-slope form, you also have the slope that's here out in front of those parentheses. You're just going to count that slope. Now, it's not written as a fraction, but you can easily turn it into one. If it's not, just put it over 1. And it's rise over run, remember, so we go down 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1. And you can just get a bunch of points on that line. You can see it's going like this. If you want to go back the other way, that's the same as 2 over negative 1. So go up 2, back 1, up 2, back 1, and I get my line. And this one's B. Okay? So your basic graphing lines. After that, we actually talked about writing equations. So I gave you both of your different types. This is your slope-intercept here. This is your point slope here. why don't you guys then take the information down below and try to plug them into those equations to get your two different formats. So try to answer these two here in the middle. What is the equation of a line? Pause the video. All right, you can check my two answers. For the first one, I got y equals -3/5 x plus 6. I just literally plugged in the slope, plugged in the y-intercept. On this next one, this is where I start to see a little bit of goofiness happen. Remember that the first value in your ordered pair is your x value, and the second value is your y value. So when you plug those in, x should go with the x, and y should go over with the y. Slope goes out here in front. You could put just a negative sign there or a -1. Either one of those are acceptable. But we end up with y minus 5 equals -1 times the quantity x minus 2. So after we kind of discussed that, we moved on to talking about vertical and horizontal lines and their equations. So it says, what are the equations for the horizontal and vertical lines through 2, 4? Remember that horizontal, that's your flat. Vertical, that's your up and down. So this is your vertical line, this is your horizontal line. What I like to think about to help me write these is I think about the ordered pairs on them. So like all these points on this horizontal line, all of them have something in common. Just see if you can think about what do all those ordered pairs have in common. And if you need to, write them out. Just looking at 5 of those ordered pairs, they all have y is 4. So that's actually your equation. Y equals 4. That's your horizontal line. We'll do the same thing for that vertical line. Think about all those ordered pairs on there. What are all of these ordered pairs? I've got 2, 0, 2, -1, 2, -2, 2, 1, all the way up there, 2, 4. Well, all of them have x equals 2. That's the equation of your line, which is counterintuitive because your x and your y-axes, x is the horizontal and y is the vertical. So if you struggle with writing your equations for horizontal and vertical lines, that'd be my advice. Think about the ordered pairs and what do all the ordered pairs have in common. Once we moved on from there, we talked about parallel and perpendicular lines in the coordinate plane and their slopes. And so there's a relationship between perpendicular slopes and parallel slopes. So it says line 1 and line 2 are neither horizontal nor vertical. They say that because every horizontal line is perpendicular to every vertical line, okay? Just remember that. It says, are they perpendicular? Explain. So if you look at the objective, the thing is that we relate their slope to determine if they're parallel and perpendicular. So that's what we're going to do. So line 1, let's talk about its slope. Slope is rise over run, or there's an equation for it. It's y2 minus y1 over x2 minus x1. So I think line 1 is here. It's got 2 ordered pairs. Let's call this the first ordered pair and the second ordered pair. Just plug in their values into the slope formula. So y2 would be -4, y1 would be 2, x2 would be 0, x1 would be -4, so it's minus a -4, which turns into a plus. So I get -6 over 4. We just want to simplify those fractions. If I take -6 over 4 and simplify it, I should get -3/2. So that's my slope for line 1. I just want to do the same thing for line 2. So pause the video and you try to do the slope for line 2 on your own. Now once we get their slopes, what we want to look at are their values. You should have gotten line 2 to be 2/3 for the slope. What we look at is this slope here for line 1 and this slope here for line 2 if they're opposite reciprocals. And if they're opposite reciprocals, that means if I take them and I multiply them, I get -1. So I multiply across, I get -6 over 6. Okay, that is -1. So you'd say, yeah, they're perpendicular. The reason being, you could say the product of their slopes is -1, what we just checked. Now, in order for two lines to be parallel, they actually no longer have opposite reciprocal slopes, or product of slopes is 1. Their slopes are going to be exactly the same thing. So here they have an equation of a line, and we're supposed to write the equation of a line parallel that has a point. So it says, what is the equation of the line parallel to y equals negative 3x minus 5 and contains this point? Well, what I would look for right here is what's the slope? Well, that's what the number in front of the x, that's negative 3. And if it's parallel, I want to have the exact same slope, and it's going to go through the point negative 1, 8. If you think back to the previous slide where we talked about different types of lines, we talked about slope-intercept and point slope. So when I'm given information, I look at what am I given? I'm given a slope and a point. That sounds like point slope form. That's my y minus y1 equals m times x minus x1. I would take those values and just plug them in. I go y minus the y value 8 equals the m times x minus the x value. Well, minus a negative 1 is a plus 1. And that's what I end up with. Sometimes they'll ask you then to put that in a specific form. If it asks for you to put that in slope-intercept form, solve for y. If it doesn't, you can just leave it just like that. So why don't you try this next one? You're writing the equation of a line this time, though, that is perpendicular and goes through a point. So pause the video and try it. So the original slope is negative 3. Opposite reciprocal of that is 1/3. You flip it and change the sign. And then we plug in that negative 3, 7 and that 1/3, and we get y minus 7 equals 1/3 x plus 3. And that is the conclusion of Chapter 3 Final Review for Geometry.